Don't take all this down. Take only the highlighting. Um, okay, fine. And you people know this that were in physics. That's why I had you raise your hand who's in physics before. Vectors are just imagine this. You can use a vector to describe the action of a plane in the sky. But what's a person looking at that tracks that? A two-dimensional screen, right? It's a little blip on the screen. So it's like imagine that you put the world on a map, and a vector is just a directed line segment where it has magnitude, so write that down. And actually just write magnitude is length. So maybe how far the plane traveled. It's the speed of the plane. Is what we represent in the real world. But anyway, just imagine that on a piece of paper. And direction. So which direction is it going? You're going to find out there's two ways to express these things. One is just, like I said, you could put the world on a map, and you could put a coordinate plane on that map. Therefore, you could use coordinates to represent the position of the object. So you'll see that one way. Another way is to express that magnitude, which is the length, and also angular displacement. Now, going back to chapter 3, as you write what you want to write here, basically all I've showed you so far is just magnitude is the length of a vector, direction is which way it goes. We'll show that with an arrow. We're going back to chapter 3. We talk about chapter 3 so much. When I give you the chapter 3 review, you should know you'll be amazed how easy it is. Like what sine of a 30? Sorry, what sine of a 30? What? What's cosine of a 60? What's tangent of a 45? What's sine of 45? Someone has not answered this once yet. You're killing me, Smalls. All right, that's a tough one. What's tangent of 30? Root 3 over 3. What does that make tangent of 60? Just the root 3, right? That's the two choices. Did I say tangent of 45?
Yeah.
What's that? 1. Here's a tough one. What's tan of 225 then? 1, because it's in quadrant. 3 in tangents. No, it's negative or negative, right? So it's positive. So you okay over there? Does that bore you? All right. Now, let's draw this. Let's talk about geometry first. Okay, a geometric representation of two vectors. And I'm going to do this with our first Mickey Mouse examples of adding vectors. The action of adding two vectors, if I have vector A, which I tried to copy vector A from here, and vector B, I tried to copy vector B from here. If I want to add these two, A plus B is you draw A, and then at the end of A, you tack on B. The action of adding these two vectors together is this red vector. That is called, physics people. Well, no, what is the red thing called? Starts with an R. It's the resultant. Okay? And we're going to see that in our last example of the day. I don't know if I'll have time to. I think where I lost my time in second hour is picking on students. Not picking on them like, haha. Picking on students to answer questions. So we'll see if I have time for that. All right, then notice what B plus A would look like. That would be draw B and then add A. Now all I'm showing is B plus A is the same as A plus B because you get the same resultant. Can everyone say the word resultant? That's going to be something we're going to talk about later at the end. That's what I screwed up with the other hour. Okay, this is what I was talking about. There's a couple ways we're going to express vectors. One way is putting the world in a coordinate plane. Actually, both ways deal with putting the world in a coordinate plane. And then one way is saying the vector's position is A comma B, at least where it's ended up at. The starting position is the origin. The ending position is some coordinate A comma B. So the one thing you have to write down as you're writing this down, this looks like a coordinate, except this is vector symbol, okay? So it's not parentheses, it's that little, I don't know what that's called.
Those are like less than and greater than something?
Yeah, but not really. They don't work that way, but you're right. Kind of looks like that. All right, so hold this off as you write that down. Okay, we got to move on. First Mickey Mouse example. Ah! Did I hit save? Oh, no. Let me try this one. Sorry, the video has to see this. When I had to restart my computer. There we go. Thank goodness I had an alternative form. When my computer shut down, it saved all those notes from second hour. I wanted it blank. Okay, here we go. This is what I'm talking about. Here's vector A, negative 8, 8. All negative 8, 8 means is vector A is this magnitude going in this direction, starting at the origin 0, 0, and ending at negative 8, comma 8 in this coordinate plane. So again, pretend this is like some sort of map that we put. We're at the origin, let's say. We're the origin. We're at the station. And then some object went this direction with a certain speed, and that's its vector. I don't know. Just trying to get your head in the right spot. And then vector B is in this position. Starting from here, it's in the 4, comma 8 position. Boom, boom. That's that vector. Now, geometrically, you'll see how this works. And then algebraically, if that's the word, it's very simple to add these two vectors. But before I do that, I'm going to do it geometrically. To add A plus B is to take A and then go at A and tack on B at the end of it. So that's 4 right and 8 up. 4 right, 8 up. There's B being tacked on A. And then the resultant is the answer. All right, so where's that located? Where's that located? Negative, come on. 4, comma. Now this goes by 4s. Okay, I got to get the calculator. Okay, so here we go. All right, so student number 17, how else could I have gotten negative 4? What could I have done with those two numbers? I just circled them, right? What do you think I could do to these two numbers to get that number without doing the geometric version? Add them. What can I do with these two numbers to get this number? Add them. Do you feel alive by answering questions? She said yes. I've done something today. All right, then let's move on to this one. Let's erase that because I like this geometric. Oh boy, I think you're canceled. Did you ask your question yesterday? I canceled you for the. Sorry, these things happen in Samuelis's weird, uncomfortable class. Some people have said, isn't it awkward in here? All right. You ever see The Office? Anyone an Office fan? That's that show is based on awkwardness. I just love it. Who? Oh yeah, that's the guy. All right. All right. All right. Here we go. So how do I subtract two vectors? Okay, we could do what student number 17 did mathematically, very simple. But physics students, what happens when you take the opposite of a vector? Goes in the opposite direction. She got it first, so I just wanted to go to her. So, but the reason is, okay, fine. So 4 right, 8 up. Instead of that, it's 4 left, 8 down. This is the opposite of B, which quite easily is just take the opposite of these two xy coordinates as well. And then we can see it goes in the opposite direction. So to tack the opposite, I didn't put that on there yet, the opposite of B, 4 and then 8 down, this is the resultant. Okay, student number, because the last time I tried this, no one said a word. 26. What's the resultant? Where does it end up at? These go by 4s. Ooh. What kind of 12? Did you say negative? Yeah, negative. Okay, and then comma? How far am I up or down? 0. Okay, this one right here. Okay. Okay, same student. What could I have simply done with this? Oh, the opposite of B? I actually would do this. And then let's erase these. What could I actually have done with the x coordinates? Negative 8, negative 4. What could I have done with them? And then what could I have done with 8 and negative 8? And then what's the opposite of A? Let's make this go faster. 8 comma negative 8. I'm not even doing anything for that, right? Take the opposite of x and opposite of y. Hello? Anyone? Oh my goodness. Here we go. Nicely done. Impressive. Most impressive. I wrote all this stuff out. In the other notes, I didn't give them this. And I really shouldn't. Because all these notes are to express how easy it is to not make this a formula. Although if you were absent and you read the book, it's presented as these are formulas you have to have memorized. So this is what I did, and you can do what you want with this. Maybe you can write this out as little, but try to make it fast. A vector can be named by the coordinate it ends at when placed in a coordinate plane. That's what we just did. The x coordinate will be called the horizontal because horizontal is right left. The y coordinate is called the vertical, up down. Okay, now this is new over here. We also will be asked to find, or at least another way of expressing vector positions and what's important about it, is find the magnitude, which you already wrote as length, right? Right? Student number, where are we at? 20, 19, 20, 21. And then the direction angle. Now, this is what I mean about going back to chapter 3. Direction angle must be written in standard position. Student number 21. What does standard position mean? What is the initial side when we talk about an angle in standard position? That was a tough one, right? Where do we always have to start with our angles, huh? Not the origin, but one of these four axes. Which one? The x-axis. Which one? Positive or negative? And if I express that angle positively, what direction does it go? Or what actually is called what? What is this called when I go in this direction? Counterclockwise. Now we got to go back to chapter 3 and name these angles this way. Bologna sausage. Again, student number 21. Say I gave you A and B. How would I find you? Me? You. How would you find you? Pythagorean theorem. So the magnitude is quite simply the Pythagorean theorem if you were given A and B. So we're saying I gave you A comma B. Look at that. A comma B. To find the magnitude is not a formula that has to be memorized. It's the Pythagorean stinking theorem. Why is he getting angry? I don't know. Now, say we had to find this direction angle. Student number 21. What side is this? What side is this? Anyone know what song I'm trying to? Well, let's go back to old school. Opposite. What side is this? What side is that? What deals with opposite and adjacent? Tangent. So to find the direction angle, which is theta, everyone should know that this is inverse tan of B over A. So this is finding these things when A and B are given. And it's basic math 2 trigonometry. Not even what we've done, even though we did review it. We started the year in August reminding you of your trig thing, SOHCAHTOA. That's what we did. Check the calendar. And then wait, there's more. Now let's reverse things and analyze how we can find A and B given the direction angle. So go ahead and take a minute to write that down. Now, now you have to get in the mindset. Oh, that's another. Never mind. Did you get hammered down with mindset last year? Your teachers? No? No posters about mindset. Your mindset has to be this. No? Yeah, right? Yeah. Oh, yeah. Like it just is there a hammer in there? And then if you weren't, they'd hammer you in the head. Come on, mindset. No? All right, anyway. Sorry. Given theta and given the magnitude, we have to find A and B now. Now, did I pick a student? Where's the calculator? Let's get this student. Hey! We got to do the stare down again? All right. What side is this? But then I'm given that. Now, I'm going to find B separately. So, given the magnitude. Now, again, this is a number. I have a number for this, and I have a number for that. What trig function deals with opposite? And what's this? You never said. Hypotenuse. So what deals with opposite and hypotenuse? So, okay, I should set it up this way. Wouldn't you agree that it's sine of theta equals A over what's represented as u, which u is and actually they use the symbol that means the length of u, which is just a length. Okay, so get used to that. I see your crinkling face. Are you all right? Okay, that's all that means. And then solve for a. So what would you have to do to both sides? Multiply it by u. Me? So basically, you don't need this. You could say, okay, I have to find a. I could go to my Math 2 trigonometry and find a that way, because this is going to be a number and this is going to be a number. Oh, I have to find a. Well, that's just sine. Do you understand what I'm saying? Everyone's just like a statue in here. Okay, that's fine. All right, and then let's erase this and get a new student. All right, because this is kind of like Common Core. Hey, you've been ducking this whole time. Okay, you're given these numbers, but now what I want you to do is find A. What side is A? Adjacent. Who deals with adjacent and hypotenuse? So, I'm given theta. I'm given this. Mr. Samuelis asked me this question in August. Find this letter. Well, this is adjacent and this is hypotenuse, so that's who? So cosine of theta equals, oh, you know what? No one said a word. Not a word. Nobody. Did you see the mistake in the notes? Nobody said a thing. Y'all just let it go. Yeah, I'm yelling at you. I made a mistake. You didn't catch it. Okay, now. All right. So cosine of theta equals A over U. Me? All right. What do you do to both sides to solve for A in this case? And I got to reverse that. Me? It's never going to get old. All right. Cosine of theta and then U. So you got to switch that. Sorry. I made a mistake in the other class. So these present themselves as formulas, but they're not. They're based off of basic trigonometry. Okay, so therefore this says you'll be asked to do back and forth. So don't write any of this. If you were absent and you knew this book was great, you'd read the book and it would present these formulas as if they're formulas, but they're not. You already wrote them down. Okay, got it? Got it? Well, no one's saying anything. I hope they do. Thank you. I think he's just saying that just to get rid of the awkwardness in the room. All right, I do have to go fast, though. So get ready for lightning fast notes, and then you watch the video that I'll present. Okay, so here's one where they give you A comma B. You have to find magnitude and direction angle. You know what? I'm not even going to bother this kid. How do I find the magnitude? I use the Pythagorean theorem. And then you know what? I'm done. It's root 13. You know how to do that math. How do I find theta? Now you got to watch it here. Again, okay, so I draw it. 3 comma negative 2. I make the triangle. This is the magnitude. Okay, how do I find that? I'm being a student that can't remember the formula. Okay, this side is the opposite side. This is the adjacent side. What deals with opposite and adjacent? Oh my gosh. Tangents. Opposite over adjacent. So therefore I have to inverse this. All right. I'll even do that for you because I know when I ask, hey, can someone type that in their calculator? You're going to look at me like you want to kill me. I got it. Everyone just sit there. Okay? Now, is that the answer that I want to put there? Nah, I mean, it is not bad, but really what we want to do is standard position this way. So what's the math, simple math that I have to do to get this answer? Add 360. Why just add? Because it's already negative, but I heard someone say 360 minus. You're right, but you know what I mean. So it's 326 what you want to write. 326.3. Simple, basic trigonometry. I can't even say it, though. Okay, then why are these no calculator questions? Again, I want to fly by this. Because you should recognize all instantaneously negative 1 comma root 3. Negative 1, root 3. This is the vector. Negative 1, root 3. Everybody should be able to tell me the magnitude right now. No, I want the magnitude, which is the length of this. It's 2. Now, not because it's the square root of 4. I did do the Pythagorean theorem with other people back in the day. Student number 10, are you okay? All right, but we should recognize these sides. By the way, what's this reference angle? So what's the angle? Don't say 60. 120. Because this is 120, 60 short of 180. If you still don't know how to do that, you're not on the bus. Now, why should this be no calculator? Negative 1/2, comma negative root through 3. What is the magnitude? Now, this is interesting. Who knows? What's the magnitude? This comes from the unit circle. I'm surprised you don't know. I thought you were a pro on this. What's this magnitude? What's the length of this vector? It is 1. Give that man a prize. Not me, someone else. No, nobody, nothing. I could do the Pythagorean theorem, but we should recognize that this is all of these side measures divided by 2. Right? So we should recognize it. And then what's the reference angle? What's the reference angle? 60. So what's this angle measure? 240. And then let's come back to this one real fast. And then I already have the answers shoved in your face here, but I'm going to erase them real quick, just so you know what you're finding. Okay? You're given the reverse. This is why I get mad. Oh, he's doing 7-4. It's more things I have to memorize. You're a liar. All you have to do is make a drawing and then just become a Math 2 trigonometric student. So I make a drawing. I draw this as 25 magnitude. I don't know. It doesn't have to look 25 inches long or whatever. Just put 25 on the magnitude. And then 41.7 ends up in quadrant 1. And then it says find the horizontal, that's A, and vertical, that's B. Okay, fine. That's the new thing for today. I need to find A, comma B. I need to find A and B. All right. So if I start with A, what side is A? What side is A in this triangle? Adjacent. I don't even need kicks or ticks. What's the magnitude? What's that called? What deals with adjacent hypotenuse? Cosine. Cosine 41.7 equals A over 25. Solve for A. Give me a break. And then how about B? What side is this? What side is this? What side is this? Okay. Anyone know that song? Well, it's a version of a December song for no apparent reason. But it's math. I sell a math CD. I take all the songs, but I put math in it. Be on sale in a week. I don't want to do that one. What I want to do is this one. Okay. Shoot. Don't look. Everyone close their eyes. Okay, good. Okay. Did you? Now you can open them. You had them open the whole time. I should write you up. Okay? All right. Now, here's what we have. We're going to take this student right there. We're going to tie him up in a rope. Okay? Then we're going to take this student right here. You're going to hold one end. This student's going to be tied up with a rope, and then I'm going to hold the other end. Ready? Okay, so what happens when the rope is tethered? We go 1, 2, 3, and we pull. Which way is the student going to have to go? In a diagonal. All right? And let's be honest. The closer we are together, is this student going to go faster or slower compared to if we were farther apart? So which one would it go faster? If we're closer or farther? Closer. I mean, let's pretend we were directly across from each other. That'd be called tug of war. The stronger student would just be pulling. That's the way this other student tied up with the rope would be. That's what this question is. Here's the student that we tied up right here. And then here's this student. We'll call this me. I'm weak. I'm sick and weak. So I only have 15 newtons of force right now. And I got the student roped and I'm ready to pull this way. And then the other student who's stronger is pulling at 22 newtons this way. Ready, set, go, pull. Psh, that student flies this way, right? That's tied up with the rope, correct? Okay, so this is two forces acting on an object. Well, when you put this together and put these dotted lines, this is called a pair. A parallel A parallelogram. A parallelogram, opposite angles are adjacent angles are supplementary. So what we started off this question, this is what students screw up all the time. The angle between the two students pulling on the rope is 100 degrees. That's what the question says. Two forces of 15 newtons and 22 newtons act on a point in a plane. The angle between the forces is 100. Okay, so what we want to do is find the resultant's force. The resultant is actually opposite. Look at the angle I'm pointing at. What angle am I pointing at? 80. So what we have to do is the angle between the forces is 100, yes, but we need to use that parallelogram property that 80 is the one that is opposite the resultant. So now when I flash this 15 across here, this is side angle side in this triangle. How can we find the length of this side in the triangle when we were given side angle side? And the answer is the law of cosines, which is going to come up here shortly. So that's how you do these last questions. You draw the two forces acting on the object. You draw the resultant. It's actually the supplement of that. Is that right there? That you use that is opposite the force. You okay? You okay? All right. Okay, so forces of 19 and 32 newtons act on an object. So this and the angle between them is 118 degrees. Try to draw that. It's bigger than 90. So one is going this way. That's 19. We'll do this one that looks longer. How much longer? 32. Quite a bit, huh? That's 32 newtons. So they're acting on an object. They're tugging. That's someone's pulling this way, someone's pulling this way. The object that gets ready to go pulled on goes in this direction. Actually, really to find a direction is to complete the parallelogram. So this is just dotted lines because this isn't the two objects acting. But to complete this, this is the resultant's movement. So again, they tell you that it's 118 degrees between these two forces. What we need to do is find this magnitude's length, or the length of this. I'll just call it U, I guess. So that's why I said you got to use powers or properties of parallelograms. You got to find the supplement of this, which is 62 degrees, I think. Yeah, 70, 180, right? Yeah. And then flash this across. And then to find the length of this, I simply focus on this triangle. All right, and then I just use my math skills that I know. And the math skills are this is SAS, and what we learned is when we have SAS, it's the law of cosines. So U squared equals 19 squared plus 32 squared minus 2, 19, 32 cosine of 62. And then you can type that on our calculator, which will show you that after I unpause. Okay, getting it moving. Cosine, I'm already in degrees. 62, press enter. Don't be all proud of yourself because I didn't square root this yet. By the way, that wouldn't make any sense anyway. 814 newtons of force. It's got to be no more than the sum of these two. Like if these two people were almost like directly next to each other pulling on this object, then it would be the sum of these two forces. So it has to be between somewhere 19 and 32 is what we're saying there. So it's 28.5 newtons of force. Now, I didn't get to tell you what newtons really are. They're in the book. I forget. I'm not a science teacher. But it does translate to pounds per, in force that we might know. I weigh a certain amount of pounds. That's the force of gravity working on me. That's why we weigh what we weigh. But blah, blah, blah. So newtons are some form of force as well that's described in the book.